All right, lesson 21, our daily summary. In this lesson, we solve quadratic equations by using the square root property and by factoring. We early this semester solved a whole bunch of equations, but it has been a long time since we have solved any equations in this class. You think back on the quest that I just handed out, there was not a single equation that you solved. The answer was never x equals 5 or x equals -2, right? You were just manipulating expressions. And factoring is another example of manipulating expressions. So this is new-ish. I mean, we've done it before, but not in a while. Okay, in order to solve this equation, x squared equals 16. Okay, I mean, you already know what the answer is, right? It's obvious. What's the answer? 4, right? 4 squared is 16, that's fine. But let's talk about, like, if it's not obvious like this one, let's talk about a method, something you can actively do to that equation to solve for x. In the same way that if I gave you this equation, what you would do to both sides is what? Subtract 3. You know what to do to both sides to get rid of the +3. Let's make sure we know what to do to both sides to get rid of a squared. So here's the technique. That's the original equation. You take the square root of both sides. It is like the equivalent of this subtracting 3 from both sides, but taking the square root is the thing that is the opposite of squaring. What is the square root of x squared? This is like a problem that could have been on the quiz, is just x, right? That's the point. And so you get x equals, and square root of 16 happens to be a nice number, so we can just put 4. But even if it weren't, like let's suppose it was the square root of 17, you would just stop. That's it. I mean, you could type it on the calculator if you want a decimal, but x equals square root of 17, done. Here's the problem. Okay, so that's the technique. The problem is, what if you take x equals -4 and you shove it right in there for x? What do you get when you square -4? You get +16, right? I'm asking you to square the number -4 and you get +16. So when we said the answer was 4, well, that was half of the answer, right? The other answer is what? -4. And it is very easy to forget. We missed the solution. X equals -4 is also a solution. The moral of the story, when you take the square root of both sides of an equation, you must put in a plus or minus. So that is right down here. Plus or minus. At the moment you take the square root of an equation, you put in a plus or minus. Because squaring will get rid of a negative sign no matter what. Taking that -4 and squaring it turns it into +16. Okay, really easy to forget. I know that you guys bring a reference sheet to quizzes and tests. You should put that bold sentence right there on your reference sheet. When you take the square root of both sides of an equation, put in plus or minus. Okay, so let's take a look at another more complicated equation that's the same flavor as the x squared equals 16. This one right here. 7x squared minus 1 equals 199 plus 3x squared. So let's do the technique that we're going to do here, and then I'll talk about what makes this the right technique for this kind of problem. It's a very special kind of problem here. Okay, first issue. I see x squareds on both sides, yes? Let's fix that. Let's get all the x squareds on the left. So if we subtract 3x squared from both sides, then how many x squareds do we have here? We got 4x squared. And then you copy the -1 equals what? 199. Okay, so far so good. This should become clear in just a minute, but it turns out I want to get the x squared by itself. So I'm bothered by the 4 and I'm bothered by the -1. I don't care about the 199. I'm focusing my attention on getting this thing by itself, okay? Which number needs to move to the other side first, the 4 or the -1? -1, right? Add that to both sides. We get 4x squared equals 200, right, by adding the 1 to both sides. Then we can divide by 4. We'll get x squared equals 50, yeah? And we know the technique for solving x squared equals 50 because it's the same technique as solving x squared equals 16. What do we actively do to both sides of this equation? We take the square root. We take the square root. So let's do that. I'm going to copy that equation again just so that I can actually put in on another equation square root both sides. Now I have already made a mistake. That last equation is incomplete. What did I forget to introduce at that step? Plus or minus. So easy to forget. It's in bold. We just said it like 2 minutes ago, and some of us have forgotten about it. It's really easy to forget. When you take the square root, you put in a plus or minus. Okay, the left-hand side is easy. What is the square root of x squared? It is just x equals plus or minus. Square root of 50 is nothing nice. But the best we can do is find something nice that's in that 50. What perfect square goes into 50? It's 25. And so this is something that was like on your quest. To remind you, the problem on the quest was one of them was rewriting the square root of 63. And a number of folks said, can't do anything with it. It's already simplified, or it's not real. It's just a messy decimal. You cannot simplify it. So the technique on the quiz is the same as the technique here. You can't take the square root of 63 and get something nice, but there is something nice in 63. What nice number goes into 63 is 9, right? 9 is a nice number inside of a square root. 7 is just what's left over because you still have to have 63. Square root of 9 comes out and becomes 3. Square root of 7 is nothing nice. It just stays there, and that is the simplified version of square root of 63. So we finish that up here. Plus or minus. Square root of 25 comes out as 5. What's still in? 2. That's it. So our answer is there. Plus or minus 5 square root of 2. That plus or minus literally is just an abbreviation that means you have 2 answers. One of them is positive 5 square root 2. The other one is negative 5 square root 2. 2 answers in one line. Okay, so that's the technique. Get the x squared by itself, and eventually you can take a square root of both sides. Don't forget the plus or minus. What's the problem with trying that technique here? There's an x. And that means the technique we just used is useless. Cannot do it. You're welcome to take the square root of both sides. That's a legal thing to do. When you take the square root on the left-hand side, what do you get? You get x. That's great. Right? When I take a square root of both sides, that's legal. Don't forget the plus or minus. You get x equals plus or minus on the right-hand side, square root of 25x. Yeah, you could pull the 5 outside, but that's not the problem. The problem is there's an x inside of that square root. So you haven't solved. I know x is by itself, x equals, but we need x equals a number, not x equals something else with x's in it. Right? And so the technique that we just did here, where eventually we took a square root, is only good when the equation has an x squared term, but no x term. That is the giveaway. Remember how we talked about our routine for the difference of two squares formula? Is it 2 terms? Is it a subtraction? Are they both perfect squares? The routine here for this very specialized technique of eventually taking a square root is one basic question. Does it have an x squared but no x? That's the question. If it has x squareds but no x's, we use this technique. Anything else, we got to do something other than this technique. Okay, so let us change gears now and solve a much broader class of quadratic equations. So here's a definition for us. A quadratic equation written in the form ax squared plus bx plus c is said to be in standard form. So the definition of quadratic equation is an equation that has an x squared as that highest power right there. That's what makes these equations different from all the equations we solved in the first half of our course. 3x plus 2 times 4 minus x equals 7 times 3 plus 5x. What is the highest power on any of the x's? 1. And the techniques that we used to solve these equations earlier in the semester are out the window for today. It's a completely different solution method when it's an x squared. That's the giveaway. All the ones we solved this semester have just been single x, x to the first, no x squareds. Now we handle x squareds. Okay, it says, turns out standard form is pretty useful, so getting one side of a quadratic equation equal to 0 is often a good first step. So let's solve here. We're going to do two different equations, this one and then this one down here. So let's take a look at that first one. Suppose that I ask you to solve this equation, parentheses 3x minus 1, parentheses 2x plus 7 equals 0. So imagine that you didn't look so closely inside of here, and you just said, okay, there's a number in there. I don't know what the number is. And then you also didn't look so closely in there, but it's just a different number, right? It's just two numbers multiplied together, yeah? And I got 0. One of these two numbers had to be 0, yes? It's just fundamental. The only way to multiply two numbers and get 0 is if one of them is 0. That is at the heart of this technique. So, okay, let's now focus our attention on what's in there. We said one of these two things has to be 0, so either 3x minus 1 is 0, and we literally write that as its own equation, or 2x plus 7 is 0, and we write that as its own equation. And those two equations I could have given you on the first day of this semester, and you'd have said, these are easy, right? You can solve those two equations without breaking a sweat. So in this case, add 1, divide by 3, we get a third. Over here, what do we do first? Subtract 7, divide by 2, negative 7 halves. Those are your answers. X equals 1/3, x equals negative 7 halves. Done. Okay? So what made this easy was two things. One, it was a 0, and two, it was two things multiplied. What do we call when we turn something like this? Let's go down here. Something like this into two things multiplied? That's factoring. And this is why we did all that factoring today and a week ago. So let's take a look at this much tougher equation in blue. X squared minus 24 equals 5x. As we said, the 0 was pretty darn useful up here. So the first step is to get one side equal to 0. Let's bring that 5x over to the other side by subtracting. And you'll notice that I intentionally put that negative 5x in the middle to really make it look like our standard kind of factoring problems that we've been doing today in last class. And so now we have x squared minus 5x minus 24. If we could somehow factor that into two parentheses, would you agree it's the same easy kind of problem that we had up above, where you just take each parentheses and separately make them equal 0? So the hard part in this one is factoring. And factoring in this case, let's go through our routine. We have three kinds of factoring, and it's always the same order: GCF, dots, box. Can you factor out a GCF? I'm looking at this yellow equation here. Can you factor a GCF out of all three? I said I highlighted too much. I'm really just looking at this. Equals 0 is just hanging out there. Okay, can't factor anything out. Is it a difference of two squares? Not even close. It's not even two terms. So what's the only thing left? Is the box. Okay, I want to make sure you have time to do the activity. So I'm going to say I did the box already on this one, but there's a lot of work between this step and this step. It's the entire box problem. Okay, but you'll take my word for it that x minus 3 and x minus 8 and x plus 3 is what you get when you do the box. But now finishing is the new process, but it's easy. Either what is equal to 0? Either x minus 8 is 0, and that is literally just written down there and really easy to solve, or x plus 3 is 0, and that is written there and it's easy to solve. And even the word or is a small little word. It's 2 letters. Write it down. I know it's a math class. You don't like to write words, but just write the word or. It's either this thing or this thing. And then you get the two equations, and we're done. Okay, so I think that is good. Next page, activity, says no calculators on any of these. I'm just going to point out here, part A and B, I see a squared term. I do not see a single R term in part A, right? What do we not see in part B? There's not a single B term, so this is the one where we're doing the whole square root business. So don't get 0 on one side, just do the square root technique. The hard ones are down below, starting at number 2. I will walk around.